Hello student, now let us see our next point, weightlessness in a satellite. We already learned last week or last lecture some points related to gravitational chapter. Is the first, we know that the critical speed, then launching of rocket. We see all these points. Now this point is weightlessness in a satellite. We already learned artificial satellite and natural satellite, so we know that. So this condition, weightlessness in a satellite, now we see. Okay, so first of all we see what is the weight of a body. So weight of a body is the gravitational force exerted on it by the earth. When a man stands on a floor, then the floor exerts normal reaction on the man equal to his weight. That is, W is equal to N. N means here normal reaction is exactly equal to mg. Okay, so this condition is called a weight of a body, because we know that weight of the body. We already know that the weight means mg, mass of the object, and or mass of the body, or g means acceleration due to gravity. So when we stand on a floor of the body, then we exerted a force on the floor, and earth also exerted a force on it. So normal reaction exerted to both sides. Okay, so N is the normal reaction force and mg is the gravitational force. Now what is the weightlessness of a body? A body is said to be in the state of weightlessness if its apparent weight is zero. So what is now apparent force? Now apparent weight means, in the case of weightlessness, it is not necessary that weight is to be zero. Weight may be more or less than its actual value, and this weight is called apparent weight. Okay, so weightlessness condition means if the weight is zero or more or less. Okay, so the sensation of weightlessness experienced by an astronaut is not the result of zero gravitational acceleration, but of zero difference between the acceleration of the spacecraft and the acceleration of the astronaut. Okay, so here given two examples, some examples. They given three cases. Its first case one is lift having zero acceleration. Zero acceleration means this lift is at rest condition and is moving upward or downward with a constant velocity. Means lift at a rest condition, so force not exerted on the body. So F is equal to 0. So mg minus n. So F is equal to mg minus n. So we get here mg is exactly equal to n. Means mg means here gravitational force, and n means normal reaction. So gravitational force and mg are same, exactly same, means both are exerted on each other. Okay, so hence in this case we feel our normal weight mg. Now case second, if the lift having net down upward acceleration. So here exerted so at the net acceleration is upward, the upward force must be greater. So AU. Okay, so here AU means acceleration. So F is equal to MAU. So it's equal to n minus mg. So n is equal to mg plus MAE, that is n is greater than mg, hence we feel heavier. It should also be remembered that this is not an apparent feeling. Okay, so weighting machine really record a reading greater than mg. Okay, in this condition, when the leaf is upward acceleration. Now leaf having net downward acceleration, so AD. So in this happens, F is equal to MAD. AD means acceleration is downward, is equal to mg minus n. Mg is the gravitational force and n is the normal reaction between object and earth. Okay, so here we get n is equal to mg minus MAD. So that is n is less than mg. So hence we feel lighter. So you remember that it is not an apparent feeling. So the weighting machine really record a reading less than mg. Okay. So these three conditions are given here. Also, the state of free fall. Is this possible if the cable of the lift are cut? In this case, the downward acceleration AD is exactly equal to G, means acceleration due to gravity. So it become equal to n is equal to mg minus MAD is equal to 0. So thus will not be any feeling of weight. This is the state of total weightlessness, and the weighting machine will record it 0. So this is the explanation of weightlessness condition, and we see your example for lift. Okay, when it's in rest condition, when it's upward position and in downward position, or is free fall, the force conditions are there. Now our next point is escape velocity. This is the last point in this chapter. So we learn here what is now escape velocity. So the minimum velocity with which a body should be projected from the surface of the earth so that it escape from the earth gravitational field. So is called the escape velocity of the body. So we know that what is the escape velocity. So escape velocity means the necessary velocity to escape from earth gravitational field. Okay, any of necessary to escape from earth gravitational influence. So its minimum velocity is necessary. Okay, so let us consider the kinetic and potential energies of an object thrown vertically upwards with escape velocity VE. So escape velocity denoted by V and small e. So when it is at the surface of the earth and when it reaches infinite distance on the surface of the earth, kinetic energy is equal to half mve square and potential energy is equal to minus gmm upon r. So total energy is equal to potential energy plus kinetic energy. So we get here half mv square minus gmm upon r. So at infinite distance from the earth, kinetic energy is equal to 0 and also potential energy is equal to minus gm upon infinity is also 0. So total energy also 0 because total energy means potential energy plus kinetic energy. So as energy is conserved, suppose energy is conserved, then half mve square minus gmm upon r is equal to 0. So kinetic energy minus potential energy is equal to 0. So rearranging this equation, we get formula for escape velocity. So V square is equal to gmm upon r into m upon m on denominator and 2 on numerator. So we get here remaining term is v square is equal to small m cancel out into 2gm upon r. So we get v is equal to root of 2gm upon r. So we know that here what is rearranging, v square is equal to the plus gmm upon m and into 2, this 2. So 2gm upon m into m upon m. So m cancel out, here r also. So we get here 2gm upon r. So taking square, and we get v is equal to root of 2gm upon r. And this value means escape velocity value. In finding numerically, we get 11.2 km per second, because here g is constant, m is also constant, and r also constant. And this g means gravitational constant, m is mass of the earth, and r is the radius of the earth. All terms are universal constant terms. So putting these values, we get the constant value is v is equal to 11.2 km per second.